Once again, the most useful diagram in order to describe what is taking place inside the engine is the indicator diagram, with the pressure as y-axis and the total volume here at x-axis. As for the spark ignition engine, we have already specific values for the volume and for the pressure that corresponds to the conditions we have for the system. So for the volume, we have the minimum volume or clearance volume when the piston is at the top dead center, and we also have the maximal volume when the piston is at the bottom dead center. The difference we have with the compression ignition engine now is that the ratio between this volume is higher than for the spark ignition engine because we have a higher volumetric compression ratio. So on this scale, the clearance volume will be closer to the 0. Then in terms of pressure, we can consider that we have the admission pressure, and as before, we'll do the approximation or the simplification, at least here, that the admission pressure corresponds to the atmospheric pressure. So there's no turbo to the engine, otherwise then the things are a bit different in the engine. So we'll especially point out the differences we have for the compression ignition engine versus the spark ignition engine, and at the beginning everything is quite similar. When the admission stroke is starting, the piston is at the top dead center and the admission valves are open. We have the same pressure in the admission line and inside the cylinder. Then the pressure is decreasing a little bit due to the volumetric expansion inside the cylinder when the piston is going down, but because the piston is slowing down before reaching the bottom dead center, then the pressures are equilibrating again, and this is the admission stroke. Second stroke. Now in closed system, the piston is going up and the pressure and temperatures are increasing. So the pressure is increasing, and here the main difference we have is that the pressure is increasing more in the inside the system because we have a higher volumetric compression ratio. But it cannot really be seen on this diagram because there is no scale here for the pressure. But here the pressure that is reached at the end of the compression stroke is higher than the end of the compression for the spark ignition engine. Then the injection of the fuel is starting. So as for the spark ignition engine, it's usually starting a little bit before reaching the top dead center. And now the injection and combustion process takes longer than it was for the spark ignition engine. So this means that during combustion, the piston has more time to go down and to start the expansion. As it was told before, the heat that is released by the combustion tends to increase pressure and temperature inside the cylinder, while at the same time the volumetric expansion due to the piston that is moving downwards tends to decrease the pressure and the temperature. So finally the profile in terms of pressure here in the indicator diagram will give a flatter profile here. So usually there's still some increase of pressure, but this phase that was called 3A, corresponding to the combustion and expansion at the same time, has a flatter profile than it was for the spark ignition engine. And then the rest of the cycle is very similar. The rest of the third stroke is again here an expansion, volumetric expansion that will cause a decrease in the pressure. Slightly before reaching the bottom dead center, the exhaust valves are opening and most of the fuel is going out. The pressure is decreasing quite fast, but remains over the atmospheric pressure that is present inside the exhaust line. And then the last stroke is again the fluid, the smoke that is pushed out with the piston going up again to the top dead center. So with the exhaust valves open, we have this last stroke, and here the exhaust valves are closing and admission valves opening in order to start again the new cycle.